Alright, so we have a gear that we've already created, and we're going to go ahead and make a point pattern that allows us to actually create the Spriograph. And what that's going to simulate is, in the Spriograph, it's going to simulate all these little points that allow the user to place the pen and trace a curve. Alright, so I'm going to start with a point in the middle, point, intersecting the axis and the face by holding Control. And then with that point still selected, I'll switch to the pattern tool. The fill pattern tool is really powerful, and we're going to select a sketch to fill in the root diameter makes the most sense. We'll fill up that center root. I'm going to use the spiral pattern, and that kind of does a nice simulation of the Spriograph. I'm going to bring the radius a little bit closer, but increase my spacing. I like that. So lots of options, ones that are further out, ones that are closer to the center, that allow us to get different curves. Alright, from my courses, there's a ring gear part to download, and we'll get started building the assembly. There's my ring gear. So my assembly is going to put this on the outside fixed, and then I'm going to bring the spur gear that we created internal and watch it spin around the inside. So make a new assembly. Alright, so for my assembly, I'm going to bring in the ring gear and add that as a default. Alright, and then I'll bring in the spur gear that I'm working on. I'll bring in the generic. So, alright, we got some issues here. Like, it looks kind of fun, but it doesn't quite line up yet. So here's what we need to think about, is when we're connecting two gears, whether they're a ring gear and an external gear inside of it, or two spur gears side by side, they have to have an axis to spin on. So this one's going to stay fixed, but if you think of two gears, there's two spinning axes. So I'll leave this here, but I do need something else that's going to spin. And for that purpose, we're going to create a dummy plate. So I'm going to create a new part. This is my dummy plate. And this is just what, it's not really a part of the Spriograph, but it's going to help us portray the motion. Alright, I'm not going to place it yet. I'll just say okay. And the dummy plate, I'm going to activate and create a sketch on its front plane, and create a circle, and extrude that 1/4 inch. Doesn't need to be that thick. Alright, back to my assembly. So let's fix this up a little bit. Let's use relations, and we want the diameter of the dummy plate to equal the outer diameter of the ring gear. Perfect. And we'll assemble this now. And this is going to be a pin connection. So we're going to assemble the outer edge, and bottom of the ring to the top of the dummy plate. So, might be hard to see, but we should be able to spin that. Yeah, can't really see what's going on there, but we'll check it out later. Okay, the dummy plate's actually going to need to exist in time before the spur gear does here. So I can still move. I can still move this around. There, we can see it moving. Okay. So the way that we're going to connect the spur gear to the ring gear is through an axis of revolution. We're going to want to spin it around. So we need an axis to exist on the dummy plate. Now it can't be in the assembly. I can't add an axis in the assembly because it has to move with the dummy plate. Alright. I'm actually going to open up the dummy plate. It's a little cleaner to see what's going on. And I'll add the axis this way. So I'll add an axis here, measured from 2 different axes. And from one of those, I'm going to change it from a distance to being, let's see if we can hold down shift and drag it. Nope. Alright, no problem, we'll make it 0 and 2, sounds fine. Okay, what is that dimension? Well, we'll use our relations to calculate it. So there's an axis now. We really want it to be one of those numbers to be 0, and the other one's going to be the distance away. Alright, back to the assembly. Alright. Okay. So now I'm going to edit definition on the spur gear and pin that to this axis. Okay? And we'll make sure it doesn't slide up and down, so we'll pin the bottom, or make sure the bottom is not translating, and everything's fine there. So now I should be able to rotate the gear and the plate. Okay? It's not meshing, it's not working around the gears, but that's because we haven't told it to yet. Okay. So when we think about how far that axis needs to be, all right, and that axis is this one, okay. D44. Okay, so this is dummy axis. Okay. So D44 is going to be a distance away that is based on the pitch diameters. So we need to show the rest of our parameters here. Oh, it's going to yell at me. I understand. So we need the pitch diameter of the spur gear, okay, and the pitch diameter of the ring gear. So the distance, the diameter that the teeth make contact on is based on the pitch diameters of each of those two components. So the pitch diameter of the ring gear divided by 2 is essentially our pitch radius minus the pitch diameter of the spur gear divided by 2. All right, let's see if that looks right. It doesn't look right. Let's check that again. Ah, I know why. Still commented out. Perfect. Okay, so the teeth might not line up perfectly. There we go. That's much better. And now we've got the gear making contact with the teeth, and we can spin it on the plate, although we still don't have any gear relations, but we have the motion we need. Okay. My spur gear here is my generic, so I think it's got 20 teeth. Let me switch back over to that one for a second. Okay. And I want to go with a 20 tooth. Okay, so we'll make a 20 tooth. Number of teeth is 20. We can add new teeth at any time. We'll just give that a save. I haven't saved anything. Shame on me. Switch back to the assembly. Give that a save. That's fine. All right. I want to make sure that this is a 20 tooth because I'm going to use that number 20 going forward. So I'm going to right click and replace from my family table with the 20 tooth. And Control G regenerates, and with the smaller number of teeth, the axis is changed and it keeps it in the right location. Okay? And now I see that it's a 20 tooth spur gear that's been added in there. All right. So let's go into applications, mechanism, and talk about our gear connections. So this is a spur gear connection. All right. And the motion axis that we're going to define first is the dummy plate to the ring. We can leave this the way it is. The second connection is the ring to the dummy plate, pardon me, the gear to the dummy plate. Again, leave it the way it is. And instead of pitch circle diameter, we'll use user defined. We're going to go 120. That was associated with the first axis, to 20, which was associated with the second axis. This is a 14.5 pressure angle with 0 helical axis. And you can see the pitch diameter shown in green for both the ring and the spur. We'll say OK, and we'll see how this works. Perfect. All right. So now this walks all the way around. If the teeth don't line up, that's not really a big deal. You don't have to have the teeth line up perfectly for the analysis to be functional. So next we're going to add a servo. And we're going to spin the small gear. Okay. So we're going to spin the small gear based on a velocity and how many degrees per second. Well, the slower you go, the better and more defined the curve's going to be, but it will take longer. I'll say 180 degrees per second. So it'll take 2 seconds to spin the small gear once. And when I run a mechanism analysis, all right, kinematic analysis, my frame rate's going to be 25, and end time. Well, this is a 20 tooth gear, okay? So after 20 teeth, it'll have traveled 20 teeth after one revolution. So to make it go all the way around, I need to go 120 teeth, which means I'm going to need to spin it 6 times, and it takes 2 seconds to go each revolution, so I need 12 seconds. All right, let's check it out. All right. Okay. So there's the analysis if I need to edit it. And I also have my servo motor if I need to edit, and the gear connection if I need to edit. All right. In the analysis, let's look at a trace curve. So the paper part is what we're going to draw the curve on. Sometimes I use a brand new part for this. Sometimes I just use the assembly itself. We're going to create a trace curve by following a point. Okay, so I'm going to pick a relatively small point here, or an outside point. That one looks good. Okay. The analysis is the set of points that we're going to use to define that trace curve. Hit preview. We've got a 6-sided curve from where that point went all the way around. If I change it to a different point and hit preview, it's a little pointier. And if I go even further out, it's going to be even smoother. Actually, that's pointier. All right. Okay. And there's your first trace curve. So this is pretty exciting. we can hide some of the points and the axes. We can hide the icons that show up for the mechanism. And our trace curve here. And this can be used to extrude something, can be used as analysis, be used as a path. I can change the properties, make the line a different color. And there's my trace curve.